In this video, I'll be talking about circuits and how they work. So this is a diagram of a complex circuit. It has both parallel and series of circuits, along with all the voltage and resistors. This will be the main diagram we use throughout this entire video. So when presented with a circuit, you'll be asked multiple things. The first thing we're going to look at is the resistance total. So that's what the question mark is next to, and by finding this, it will help us find everything else that we need to fill in. So in order to find the resistance, we need to take the parallel circuit, and we need to do the inverse of 1/7 plus 1/4, which are the two circuit resistors combined, and that would give you 2.55. In order to find the series circuit, you must add 6 and 3 together to get 9. And then to find the resistance total, you would just add the parallel circuit and the series circuit together to make a total resistance of 11.55. So now that we have the resistance total, we need to find the current total. The current is represented by I. In order to find the current total, you must take the total voltage, which is 15, and divide it by the total resistance, which is 11.5. So the current total is 1.3. Now that we have the current total, we can now look at the currents in each resistor. I have highlighted current 3 and current 4 because they're directly in line with the battery, therefore the voltage would not change. So since current resistor 3 and resistor 4 are a series, they will not be affected by parallel since they're the same circuit. So the current of 3 and the current of 4 are both 1.3. This is because they run through the same wire. So the total current of the circuit, which is 1.3, would also be the same for these two. Now that we know the current for 3 and 4, we can now find the change in voltage. So that's what we'll do on the next slide. In order to find the change of voltage, you must take the resistant, or the ohma, and then you must times it by the initial, or the current. So you would do 1.3 times 6 for voltage of number 3 and get 7.8. And then for voltage of 4, you would do 3 times 1.3, and you would get 3.9. Now that we know the voltage of 3 and 4, we can now begin to find the voltage of 1 and 2. In order to do that, we add the voltage of 3 and 4 to get 11.7, and we know that there's a total voltage of 15. So we would do 15 minus 11.7, which would give us a remaining 3.3 voltages left. So that would mean that voltage 1 and voltage 2 would both have a voltage of 3.3. This is due to only having a certain amount left, and we don't know what their current is, so they both just get a voltage of 3.3. Now that we know their voltages, we can begin to determine their current. In order to determine their current, you must take the voltage divided by the resistance. So for current number 1, it'd be 3.3 divided by 7, which would give you a current of 0.47. And then for current 2, you would do 3.3 divided by 4, which will give you a current of 0.825. So now that we figured all the currents and voltages out, this is what the final product would look like. So really, it's kind of just like a step-by-step process where you use resistance total to find current total, and then from there on, you just use formulas to fill in the rest of the chart. Thank you for watching. This is Currents and Circuits.